So now we have our smoothed normalized image and we want to analyze it. I will show you just two ways of doing it. What we do here, at least at the Comma Science group for the clinical side. One is to obtain a global SUV measurement. So you saw already how to obtain an SUV image. I will show you how to extract the global SUV from the patient brain. And the second one is to use SPM to obtain, to use a Arianna voxel-wise analysis and look at areas of hypometabolism or relatively preserved regions within the brain. So localizing the areas that suffer the most damage or the areas that are most preserved. Okay, so for the SUV part, the thing with SUV is that, as you saw, we cannot just take the image containing the radioactivity, or because the radioactivity is influenced by many things, patient weight, time from injection, etc. So we have to use a standardized measure that is the SUV in our case, the standardized uptake value that Tommaso talked about and that Claire showed you how to compute. As you can see, when I'm transforming an image from becquerel per milliliter, so radioactivity intensity, to SUV, I'm not really doing anything, if not really rescale the image. So the shape, the distribution of values is the same. What changes is really the scale that I'm working on. And the scale, and when I use SUV, the good thing is that this value is not comparable. When I have my patient, I want to compare it to the healthy controls. If I transform my image into an SUV image, I can compare it to the healthy controls. So how do we do this? So we extract a global brain SUV in our case, and which means just we have a mask of the gray matter within the brain that I will show you where to find. And we have to take the normalized image and extract the global value in this image from this mask. Of course, we need to use a normalized image because the mask is in MNI standard space, and we have to take an image that is also in MNI standard space. We don't use smoothing because, as you saw, smoothing really takes, really kind of spreads the signals around. And for this global analysis, we prefer to really just get the signal from where it is. I mean, it's a choice. It doesn't have to be done this way necessarily. We prefer for the global analysis to really just use a normalized image to really, let's say, favor special specificity over comparability, because here we just really have a mask, we extract from it, where we're not comparing anything voxel-wise with the healthy controls. Okay. Now I will show you how to do this. So how to extract something, a mean value from a mask and an image. This is how the SUV distribution looks like in healthy controls. And once we have extracted the SUV globe, the SUV global value in the patient in the gray matter mask, we just need to apply a simple formula to derive the decrease in global, the average decrease in global SUV. Okay, so we go to MATLAB. So I change my screen again. Yes, so for simplicity, I am assuming that we already did what Claire did before. So we have already computed the SUV image of our patient, which here I already did. Actually, I didn't do it, my script did it, and I will show you how to use the script to do everything later. So here I have my normalized image containing SUV values. I can open it in MRI Cron, and you can see here that the value is around 5. That's again quite common in this kind of patients. It would be higher, of course, in a healthy control. So I have this image. To extract the value, what I suggest you to do, I mean, you can do it actually manually with some commands in MATLAB, but there is a very nice toolbox that you can use. And you have this toolbox inside a function, actually, not even a toolbox, a function inside the coffee break FDG-PET code. So if you click here again and go into other functions, And you can see here the whole path if you lost me. Okay, so here are the functions. You have this function called rex. Either you can have this function added in the path, or you can just move into the folder where this function is. And after doing this, you can actually call this function. So I will just type rex, enter, and rex opens. And it is very nice to, I suggest you to use it if you ever need to extract something from an image and a mask. So in sources, I just select my image that I had to go and get. So my image is here, no, and I was here, sorry, here, patient image, automated SUV, so here, so normalized SUV image that I have computed or the script has computed. ROI is this regions of interest and is my mask. The mask that you use, you also have it inside the coffee break code folder. So if you go into mask templates, you have this MNI gray mask, and this is the mask that I showed you in the slides before. So you have uploaded your source image, that is your normalized SUV image. You have uploaded your mask, and now you want to extract within this whole mask, so at ROI level, the mean. So everything we just leave as it is. So we extract, we say, okay, we want to take everything that is inside the mask. And here is the SUV of the patient, about 4 point something, and Rex saves a TXT file that you can open, and you can see here, this 4.14 is the value of the global SUV in our patient. So if we take the formula, we can just compute what does it mean. So our LV controls, so just let me take it again, sorry. So the global SUV is 4.1 divided by the mean in our LV controls. I just simplify decimals, but okay, it's fine. And perfect. What did I do wrong? Yeah, sorry, I'm thinking I am working in Excel, probably. I apologize. So without apologies. So I just write the formula, here get the result. So we have a 47% decrease in this patient in the global metabolism in the brain. So this is not the worst you can see, but it's quite huge. So this is something we observe usually in patients with minimally conscious state minus, maybe, I mean, there is not a perfect agreement with the diagnosis, but it's quite huge. And that's it. So you just really need to compute the SUV image that Claire did, and this is really the hard part. Here you just need to take a mask of your region of interest, in our case, the global mean. You extract the average using Rex toolbox, and you get your value. We just compare it to the mean of the LV controls, and that's it. So you have your information, and we will see later with GIGA how to interpret these values and show some real clinical cases. So we will talk about this later. So we're just going to the technical side now. So this is for the SUV. Are there any questions? Otherwise, I would move we don't do now the breakout rooms, because these are really quick things, and I think you can replicate it yourself watching this video that will be uploaded on Indico. So